Good morning, everyone. Hope all is well. And we're just waiting for everyone to connect, and we'll get started.
When
All right, looks like we are pretty much good. Got a few still trying to connect. But did anybody have any questions on anything? Anybody try anything, get stuck? So should we have completed? There's no penalty for not being completed up to 9.6 at this moment. Just know that, excuse me, that's where your first test, that's the block of homework up to 9.6 that you need to have completed before you attempt your first test. So you don't necessarily have to have it completed right now, but just know that, before you take your first test, that's the marker. Then you take your first test and then go from there.
Okay, thank you. I have a follow-up question to that, just for clarification. For the test, right? I printed out the syllabus. It doesn't really have a date, and I know we're scheduling it with the proctor test with the other guys. So we just do that when we feel we're ready, or like how does that work?
Yeah, you have the flexibility to do that when you're ready. Just that
Okay.
the end of the semester ain't no flexibility on that. So you know what I mean. So you
Yeah.
don't want to wait all the way to December to start taking tests. So you're supposed to be progressing as we progress through the course. And yeah, now there is I do have the right at a certain point. Like if you haven't met a certain, like you haven't gotten a certain place or hadn't hit a certain progress, at least in your homework by a certain time, and I'll let you guys know about that. I can, like, hey man, like I can, you can be dropped. I will let you know. So let you know that, hey, you need to pick up the pace, because there is a pace that you do want to, keep up if you're trying to be successful in the course. So, 5 weeks from now, you don't want to still be looking at 9.6, in other words. So, yeah.
Yes, sir. Thank you.
Yep. Not a problem.
Mr. Tucker.
Yep.
I ain't really hear what my man said before me, but you said the first test is on everything we review until 9.6. What'd you say?
Yep. As a matter of fact, hold on one second. Let me pull up my math lab, and I'll show you guys, so you'll be able to see it for yourself and know where to look for yourself.
Okay.
All right, we go. So your assignments. So here are your assignments. So we've talked about all 5 of these sections up to 9.6. And so they give you a study plan. It would be in your best interest to at least take a look at the study plan and the review. But here's your test right here. And so now it says of 1. That's just a marker. We can always adjust that. If you don't score the score that you need, you need to score at least a 75. If you don't score that, then I can adjust your attempts, but you just have to let me know, and so that we, so that can be done. Whenever you're ready to take a test again or whatever, you will let me know, and that can be adjusted. But your first block of homework, hold on one second. Your first block of homework is right here: 3, 3, 4, 8, 5, 6, 9, 5, 9, 6, and then that's your test. And then the next one is after we've done chapter 10, 1 through 10.6 will be your next test. All right, so I heard somebody say something, unmute. Oh, so that wasn't anybody? Okay, any questions on anything I said? Anybody
Yes,
good?
I have one.
Mhm.
So the test number 1, is that one we are supposed to email before doing it?
Yes, so all of your tests, you want to email, I mean, if you're ready to, ready to knock them out, let me see, you email Mr. Davis. Just trying to find a place to write. I'll write it right here. And his email is jldavis@tcc.edu. And make sure you CC me. That would be Tucker @tcc. I will spell at tcc.edu. And let them know you're ready to take a test. And he'll shoot you the schedule and the procedure that you will take on in order to do so. So once again, nothing is in person right now. You would do it through Zoom, and he'll tell you the process. Once again, you just CCing me so that there is somebody else who's a witness to that email. And so
Yeah. Oh, thank you.
Yep, not a problem. All right. Anything else? Anybody else? As far as that is concerned, where we are, all the stuff like that. Okay. Anybody have any questions? Anybody try anything? Get stuck on anything? Anybody try anything in math lab? No. Oh no. Oh, I had this stuff right there. Wow, I had it right there. Okay. That's funny. All right. So okay, so we'll talk a little bit about graphing today. I won't fill up the whole class with lecture. Just introduce, probably do 10-1. We'll see about 10-2, but yeah, I won't take up the whole class today with graphing. But 10.1 is the rectangular coordinate system. All right. So your Cartesian coordinate plane is what we will be graphing on. It's made up of it's made up of a horizontal axis, which is your x-axis, vertical axis, which is your y-axis. They intersect at the origin, what we will call our origin. The coordinates of your origin will be 0, 0, 0. They create 4 quadrants going counterclockwise, quadrant 1, 2, 3, and 4. To the right of your origin, positive values. To the left of your origin, negative values. Above your origin, positive. Below your origin, negative. To get into quadrant 1, you have to make 2 positive moves. Quadrant 2, negative, then positive. Quadrant 3, 2 negative moves. Quadrant 4, you go positive and then negative. So we will be graphing by what we call ordered pairs, called ordered pairs because the order matters. So it's always going to be your X move first, then Y. So that means your horizontal first, then your vertical move. So you think about X comes before Y in alphabet. You walk to the elevator, go down. You run, then jump. It's always your horizontal move first, then your vertical move. All right, now let's scroll up. Still copying. All right, so let's graph a few points. All right, I'm gonna erase some of this stuff just so we can walk through it. All right, so first point is +2, +5. So you always start at your origin, as far as your move is concerned when you're trying to graph a point. So you start at your origin and go to the right 2 because that's a +2, and then go up 5. So that will be this point right here. And that puts us in quadrant 1. All right. Next one, we have -1, -3. Once again, we start at the origin as far as graphing is concerned, graphing these points. And emphasizing that because of something that's going to happen later. But when it comes to graphing points, you always start at your origin. Okay. Start at origin. So you go to the left 1, down 3. That'll put us right here. That's -1, -3. And that's quadrant 3. Next one, -4, 2. So I go to the left 4 and then up 2. That's quadrant 2. And then fourth one, we go to the right 1, down 5. That's quadrant 4. Questions on those 4 points before we look at fifth and sixth one? All right. So 3, 0, start your origin and then go to the right 3, but we do not move for y because it's 0. So that's not actually in either one of the quadrants. It's actually on the x-axis. And then for that last one, 0, 3, x is 0, so we don't move left or right for x, but we just go up 3. And that's on the y-axis. All right, any questions on any of those points? All right, can I scroll up? Very good. All right, so they introduce solutions for equations. We're not going to be solving in this section, but they just introduce it because of your graphing relationship. Solutions on and basically are an ordered pair that when you plug it into the equation is true. All right. So if when you plug in the ordered pair into the equation, it is not true, then it's not a solution. Excuse me. So if we look at this first example under solutions, we have 4x minus 3y equal to -2. So that's the whole equation. Then they give you this ordered pair to plug in. All right, so 1, 2 is our ordered pair. Don't forget that your first value is always x, second value is y. And we plug those in accordingly. That's what we did. Oh, okay. So that's what I did right here. 4 times 1 minus 3 times 2 equal to -2. If you were to do the work, 4 times 1 is 4, 3 times 2 is 6, 4 minus 6 is -2. So that works out. So that means that 1, 2 is a solution for the equation 4x minus 3y equal to -2. All right. So what that means for us is that if I were to graph this line right here, 1, 2 would be one of the points on the line. So that's what I was doing right here. But there are infinitely many solutions to a linear equation because that line represents all of the solutions that are created by the points that are on that line. So every point on that line is a solution for this equation. So there are more than one ordered pair. So like I mentioned, there are infinitely many ordered pairs that will work.
We just check in to see if that particular order pair is true.
Exactly. Mm-hmm. And they're not asking you to find any other ones or anything like that. They just want to know, is this, like you said, that particular one? Is that one? Basically, is that a point that will be on the line if you were to graph this? All right. Very good. Scrolling up. All right. So this next one, y equal to 3x minus 5, they give you two ordered pairs. So you just plug them in separately. So you have 2 and 3 as the first order pair, 3 and 4 as the second order pair. Once again, if I scroll up and you still copying something, that'll let me know. So there you go. First one, 2, 3. Over here. So I plug in 2 for x, 3 for y. So that's 3 equal to 3 times 2 minus 5. On the right, 3 times 2 is 6 minus 5, which is 1. You have 3 equal to 1. So that's not a solution. Then over here on the right, we have 3, 4 is the order pair, plugging in 4 for y, 3 for x. So 3 times 3 is 9, 9 minus 5 is 4, so you have 4 equal to 4. So that one does work. All right, any questions? Any questions? All right, we good. Scrolling up. Okay. So when it comes to graphing linear equations, there are 3 methods that we're going to cover. The first book, the original book that we had when we first started teaching virtual and stuff, it was chapter 5. But this time for you guys, it's 10.2, 10.3, and 10.4. The first method is your XY chart. Second method will be your intercepts, graphing using intercepts. And then third method is graphing using your slopes. And like I said, each one of those are your sections. All right. So we'll look at the first one. Hold on one second. See how many I got up here. And 2 is. See, normally I do all those together and leave slopes for later. We'll see. All right, so first method is XY chart. Let me erase some of this stuff so you can see the process. All right, so we have the equation y equal to 2x plus 1. And we want to graph it. So notice I have right here, you choose 3x values. Now, normally I choose 3. Really, all you have to do is 2. I'm used to, my whole process goes back to when we did not have all the computers and we always did 3 as a system of checks and balances. So I'm always used to doing 3. Really, you only have to do 2 because my math lab only asks for 2. You can only graph 2 points to create your line with that graphing tool that they have. So really all you need is 2. I always do 3. I'm always going to do 3. So just, throwing that out there as far as that is concerned. Whenever I do the XY chart, I always do 3 values just out of my old habits. So I have -1, 0, and 1. Once again, you choose those values, and I'll show you why it doesn't matter. And before we finish this problem, but just remember, whatever you choose, you have to graph it. So if you choose 1, 50, and 1 million, just remember you have to graph those 3 points. So -1, 0, and 1 values I chose. You could have done 1, 2, and 3. Either way, it's going to still give you the same line. All right, unmute it. Okay, all right. So now you're going to plug those values in for x and find the corresponding y value. All right, so that's what I'm doing over here. So when x is -1, what is y? Plug in -1 for x. 2 times -1 is -2. -2 plus 1 is -1. Let me do this. I want to use another color.
I said, next time get in the belt. Tired of telling y'all the same thing over and over again. I said, stay out of there.
Oh, try to get it. Why won't let me mute? All right, well, I think you're straight. I was trying to mute it, it wouldn't let me do it. All right, so -2 times -1 is -2 plus 1. That's -1. So when x is -1, y is -1, just so happened to be the case. Next one, 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. And then 2 times 1 is 2. 2 plus 1 is 3. Trust me, I understand. I was trying to save you. I was trying to find a mute. It wouldn't mute it for you. Any questions? On how we got those values? Once again, you choose your x values, then you plug them in for x, find the corresponding y value for each. All right. Once you do that, you go ahead and graph each one of them individually and then connect the dots. And I'll scroll up in a second. Just want to give everybody a chance to copy it down. And then we'll have our line.
You just got the y by just doing the equation with the numbers you chose.
Yes, exactly. All right. So if you were to graph those 3 points, -1, -1. So you go to the left 1, down 1. That's this value right here, or point. Then 0, 1. Don't go left or right for x, but then go up 1. So that's this point right here. And then go right 1, up 3. That's this point right here. And once again, when you connect them, that'll give you your line. So notice that I have arrows going in each direction, and that goes on to infinity. So in other words, what that means is if you were to choose, let's say you chose x to be 10, 10 would be somewhere over here. And if I go all the way up, it would give me a point that would still connect with this line. And it creates the same line. Or if I had, let's say if I chose x to be -100, well, -100 would have been way over to the left, but it will give me a point that's way down there that will still connect to this line and give me the same line. Once again, so you're not limited as far as values you can choose for x, but you're limited to how much space you have to graph and what you're trying to graph. So that's why it's easy to just choose values that are close to each other. If you don't want to do a negative, 1, 2, 3, choosing something close to each other so that you can graph with no problems. All right, questions before we do another one? Make sure we're okay. All right. Now let's do one that has a fraction involved. So right here is the problem. We have y equal to negative 3/5 x plus 2. All right, so whenever you have a fraction involved, you want to be strategic in the values that you choose, and it will be based on the denominator. You don't want to have to graph fractions if you don't have to, and you don't have to if you're strategic in the values that you choose. So if I have a 5 in my denominator, I want to choose multiples of 5. So we're talking about 5, 10, 15, 20, or something along those lines. If I had a 7 in my denominator, I would choose multiples of 7, 7, 14, 21, 28. Same thing, 10, multiples of 10. If I had 11 in my denominator, multiples of 11. So whatever your denominator is, you want to choose values that are multiples of that denominator. That will allow the denominator to divide into your number evenly and just remove the idea of decimals altogether. So what I chose here was -5, 0, and 5. 0 is always a good one because 0 will cancel out the fraction completely. But then from there, 5 and -5 I chose because of that denominator. Any problems before we substitute in?
So you telling us that just to keep it easy on us, just try to do it with the multiples of the number, if it's a fraction.
Yes. Yeah. If that was a 7, I would do -7, 0, and 7.
Okay.
If it was 11, -11, 0, and 11. All right. So first one, -5. I want to erase it. I'll just walk through it, but this is it right here. Plugging the -5 in where I see x in the original problem. So we have -3/5 and multiply it times -5. You can rewrite that as a fraction if you like and just multiply across. So -3 times -5 is +15. 5 times 1 on the bottom is just 5. So we have 15/5. Then 15 divided by 5 is 3. 3 plus 2 is 5. So when x is -5, y is +5. All right, any problems? Do the same thing with 0. So here, -3/5 times 0 is 0. Then 0 plus 2 is 2. All right. And then +5, plugging in +5. Same thing as 5/1. Multiply across. -3 times 5 is -15. 5 times 1 on the bottom is 5. So -15 divided by 5 would be -3. -3 plus 2 is -1. Any problem with any of those substitutions and then simplification before we go any further?
Those are
All right. So we have those 3 points, -5, 5, 0, 2, and 5, -1. So -5, 5, I go to my origin, go to the left 5, up 5. That's this point right here. 0, 2, you don't move anywhere for x, but just go up 2. So that's this point right here. And then 5, -1, go to the right 5, down 1. It's the point right here. And that's your learn. Connect the dots. That's your learn. Any problems? Any problems? Can we scroll up? So that's the first method. You plug in x values, you choose your own x values, plug them in, then find the corresponding y value for each one of those x values. Graph the points and connect the dots. Some questions may not show up until you actually, try to do them. So that's understandable as well. Any problems? Check some real quick. Graphing the equations, intercepts. So that's 10, 1, 10, 2. We'll do, we'll pause right here because you guys got work to do. Check something real quick. All right, so some of you are working with a good pace, and then we have some that most definitely you want to get in there. Make sure you don't get too far behind. Oh, where my stuff at? So, do we do this one? 10, 7. If I do this one, and then slopes would be, yeah, let's do this. Let's do this one because this is short, and then we'll use slopes next class, and just do slopes on that one class because that's a good section to just focus on slopes. So let's do intercepts, and then close out. And then next class, we'll just focus on that one section of slopes. Let's see if you guys have any questions on that. So all your intercepts, the second method of graphing. Your x-intercept is where the graph intercepts or crosses the x-axis. Your y-intercept is where the graph crosses or intercepts the y-axis. So there's a key characteristic for all x-intercepts, key characteristic for all y-intercepts. And so for x-intercepts, x is always 0. For y-intercepts, I say x-intercepts. For x-intercepts, y is always 0. So, and then for y-intercepts, x is always 0. So whichever one you're trying to find, you let the other variable be 0. So you'll see how we do that in a second.
Mr. Tucker.
Yep.
So when it's say that one more time. When it's always a 0. Say that one more time.
Oh, it's right here. It's right here. So for your x-intercept, y is always 0. And then for your y-intercept, x is always 0. Yeah. So I was just repeating what I had written down. That's all. Yeah. Also, you see in the diagram over here, your x-intercept is on the x-axis. Y-intercept is on the y-axis. That's what we're talking about, where it intercepts or crosses x-intercept. I mean, the x-axis and the y-axis. So. All right, now scroll up, try to go ahead and view this. I'm still copying. All right, so this type of method is always beneficial when these two can divide into this number right here. And you'll see why in a second. So let me erase some of this stuff. So we have 2x plus 3y equal to 12. And we want to graph using our intercepts. It doesn't matter which one you find first. It doesn't matter if you find the x-intercept first or the y-intercept first. Just make a decision and then flow with the characteristic that applies to that one. So when it comes to your x-intercepts, remember your y is always 0. And so that's what we did here. I plug in 0 for y because I'm looking for the x-intercept. 3 times 0 cancels and leaves me with 2x equal to 12. Then divide by 2 to solve for x. Twos cancel and x is equal to 6. All right, so your ordered pair is going to be 6, 0. Because remember, y was equal to 0, and you just found 6 for x. All right, somebody in the chat. Oh yeah, I most definitely will post. All right. So most definitely, don't forget I post all the lectures. So yeah, whether anybody look at them or not, I'll post them. So yeah, you'll get the lectures. Every lecture we do, I'll make sure you guys get. Yeah, not a problem at all. Sorry you having issues, that connection issues. I know this whole stuff, all this stuff is a trip sometimes. All right, so the next one, to find your y-intercept, you plug 0 in for x. So remember, whichever one you're trying to find, you plug in 0 for the other one. So we look for our y-intercept, so we plug in 0 for x. 2 times 0 cancels out, leaving me with just 3y equal to 12. And then we can divide by 3. 3's cancel. 12 divided by 3 is 4. So don't forget, x comes first. So this time, x is 0, and then y is 4. So that's your order pair. Any problems? So now you graph those 2 points. And that's your learn. So we have 0, 4. You don't go left or right, but just go up 4. And then for 6, 0, you go to the right 6, but don't go up and down because y is 0. Those will be your 2 order pairs. All right, any questions before we do another one? Scroll up, everybody good? All right, next one, 5x minus 4y equal to 20.
Watch the road, dude. You gotta stop.
All right, that wasn't for me, right? We good?
Sometimes it doesn't work very good when they're in cases.
All right. All right, I got that one. Okay, okay. I thought I was in direct violation. I was scrolling up.
Hey, Mr. Tuck, can you scroll up one more time to that last one? That
Yeah.
I just want to check one thing.
Yeah.
Oh, it was a 4. All right, that's all. I was just making sure it was a 4.
Okay. Yep, not a problem. All right, so the next one, 5x minus 4y equal to 20. So once again, make a decision which one you're trying to find. Not a problem at all. Make a decision which one you're trying to find first. I decided to go ahead and find x and this up first. So let y be equal to 0. Plug in 0 for y. When you do that, 4 times 0 cancels, leaves you with 5x equal to 20. Then divide by 5, x is equal to 4. So that ordered pair is going to be 4, 0. All right. Next one, for your y-intercept, let x be equal to 0, plug in 0 for x. 5 times 0, 0 cancels out. Don't lose that negative that's sitting in front of your 4. That's a minus 4, so it stays negative 4. Now you divide both, excuse me, divide both sides by negative 4. Y is equal to negative 5. All right, problems, any problems? And put that in there, so that's 0, negative 5, that's your ordered pair. So from there, graph those 2 points. 0, negative 5 means you don't move left or right for x, but you go down 5. And then for 4, 0, you just go to the right 4 and don't move up or down. And that would be in line.
Is anybody graphing the points on the calculator or something? Because I ain't got nothing to graph the points on. I mean,
Well, you're gonna graph them in my math lab. If that's what you're asking. Yeah. So I'm doing them on paper. I mean on the graph, the chart that we're doing right now, but you're gonna have my math lab and they'll have a graphing tool for you to do this on. You just need to know what points you want to graph.
Okay.
Yeah. And if you have any issues, anybody have any issues with that, always feel free to ask. And I'll make sure you're straight when you get there.
I got one more question. Should I get a scientific calculator for this class or what?
You don't need it. You can get it, but I don't think you need it necessarily. Let's see, we're gonna do slopes. It would be to a benefit to have one, but I wouldn't spend, dumb amount of money on one unless you're going to use it. Like if you got to go to pre-calc, calculus, and all the stuff like that, and you're going to use it for those type of classes, then maybe you can go ahead and invest in a graphing calculator like a TI-89 or something like that.
Okay.
You don't need this for this class though. You see what I mean? A $20 calculator might not even need one that costs that much for this class, but if you just want it for reassurance, and yeah, it wouldn't hurt. All right. Last thing in this section, talking about horizontal line and vertical lines. So notice, let me go back up. Notice our equations up to this point had x and y in the equation. So now when it comes to equations that just have y equal to a number, that means that y is always that number. So here we have y equal to 5. So no calculation when it comes to these. Y is always 5 when you see y equal to 5. And x can be anything. All right, so no calculation, just observation. I see that y is equal to 5. I can let x be anything. That's what I did here. And then when you graph those 3 points, it will give you a horizontal line at 5. So -1, 5, you go to the left one, up 5, 0, up 5, and then go to the right one, up 5. It gives you a horizontal line at 5. So when all you see is the letter y equal to a number, that's a horizontal line at that number. And then when it comes to vertical lines, the opposite, you would just get the x variable. That means x will always be that number and y can be anything. So here we have x equal to -2. So it means no matter what's going on with y, x will be -2. And so if I graph that point, those points, I would go to the left 2, up 1, left 2, up 2, left 2, up 3, and it gives me a vertical line at -2. So those are the situations in which you will get a horizontal line or a vertical line. All right, any questions on anything? So,
Yes, sir.
all right, thank you, sir. Thank you, sir. So try the stuff out. See if you get stuck on anything. Don't forget, you are supposed to do your homework. Homework is mandatory, so make sure you're in there knocking the stuff out. And then when you're ready to take your test, make sure you email Mr. Davis. After we get, probably after chapter 10, I will have a opportunity for you guys to take a test during class time as well. But if you're ready, I wouldn't wait for that. Go ahead and knock the stuff out while it's fresh and go on from there. Next class, we will focus on slopes, making sure we're good with that before we move forward, past graphing or whatever, and go from there. All right. Any questions? Anybody? Good? Straight?
Good, thank you.
Thank you, sir. Thank you, sir. So have a great weekend. Be safe. Have a great Labor Day weekend. And I will see you guys Tuesday. All right.
Have a great week.
Thank you, sir. You do the same. Take
Take
care.
it easy, Mr. Tucker.
Thank you, sir. Appreciate it. Everybody have a good one. All right.